All right, everyone, welcome back to AI Paper Podcasts, the show where we take a look at all the latest and greatest in AI research.
That's right. And today we're going to be talking about something really exciting, something that I know a lot of people have been waiting for, better text-to-video generation.
Yeah, I mean, we've seen some amazing progress in this area lately with models like Sora and others really pushing the boundaries, but there's still this gap.
Absolutely. There's a huge gap between what we want these models to do and what they're actually capable of.
Like we can tell them to generate a video of a cat playing with a ball.
Yeah.
And they can do that pretty well.
Yeah.
But what happens when we ask for something a little more out there?
Yeah, like a cyberpunk rabbit eating a carrot.
Exactly. Or a glowing firefly in a jar at night.
Yeah.
These are the kinds of requests that really trip up current models, and that's where this paper comes in.
This is where VideoUFO comes in.
VideoUFO, tell us more.
So VideoUFO stands for Video User Focused, and it's a new million-scale data set that's designed to address this gap between user prompts and model capabilities.
Okay, I like where this is going. So they're basically saying, let's train these models on data that reflects what users actually want to create.
Exactly, and that's what makes VideoUFO so unique. They didn't just scrape random videos off the internet. They started with 1.67 million user prompts from another data set called Vid Prom.
So these are actual requests from people trying to generate videos.
Real-world prompts, real-world desires. And you know what they found?
What'd they find?
An incredible amount of variety. I mean, we're talking everything from dance and alien to ancient Egyptian, and yes, even that cyberpunk rabbit eating a carrot.
Hold on, a cyberpunk rabbit eating a carrot now. It's something I gotta see.
It's in there. Trust me, you'll want to check out the data set. But the point is, this user-focused approach has resulted in a data set that's far more aligned with real-world creative needs than anything we've seen before.
So for those of you just joining us, we're taking a deep dive into VideoUFO, a million-scale data set for text-to-video generation. And the key takeaway here is this data set is built from real user prompts, which means it's directly addressing that gap between what users want to create and what current models are capable of. And they've got some pretty fascinating topics in there. We're talking cyberpunk rabbits, people.
Cyberpunk rabbits and so much more. And this is just the tip of the iceberg. We're going to get into the nitty-gritty of how they built this data set, how it compares to existing ones, and the exciting results they're seeing in terms of model performance. So buckle up. This is where things get really interesting.
Okay, let's unpack how they actually built this massive user-focused data set. They started with those 1.67 million user prompts. They clustered them into 2,000 topics. What happened next? Did they just start blindly downloading YouTube videos?
Not quite. They use those topics as search terms on YouTube, but with some very specific criteria.
Okay, what kind of criteria?
They only wanted high-resolution videos under 4 minutes long and with Creative Commons licenses.
Makes sense. You don't want to train a model on blurry, low-res videos, and respecting copyright is crucial.
Absolutely. But even with those filters, they ended up with over 586,000 videos.
Wow, that's a lot of data. But weight training on entire videos would be chaotic, right?
Right.
Imagine a model trying to learn from a video that jumps from a cat playing to a cooking tutorial.
You hit the nail on the head. That's why they took the extra step of splitting those videos into shorter, semantically consistent clips.
Semantically consistent, what does that mean?
It means each clip focuses on a single coherent concept. They used a shot boundary detection algorithm to find natural transitions within each video, ensuring that each clip tells a mini-story, so to speak, this way. The models are learning from focused chunks of content rather than a jumbled mess.
Okay, I'm starting to see how this meticulous approach to data curation is going to pay off. But they didn't stop there, did they?
Oh no, not even close to further enrich the dataset. They generated captions for each clip, both brief and detailed ones. And for the detailed captions, they used a really interesting model called Qwen2VL7B.
I'm sensing a theme here, using AI to build a better AI dataset. Tell me more about this Qwen2VL7B. What makes it so special for this task?
Well, it's a multimodal large language model, which means it's been trained not just on text, but also on visual data.
So it can actually understand and describe what's happening in a video.
Exactly. It can capture things like the relationships between objects, the overall mood, even the camera movements.
So it's like these detailed captions are almost like mini screenplays for each clip. They must be incredibly valuable for training models to connect visual content with language.
Absolutely. But even with this incredibly detailed and carefully curated data set, they didn't stop there. They knew that even with specific search terms, some irrelevant videos might have slipped through the cracks, so they incorporated a final verification step.
Okay, I'm on the edge of my seat.
Yeah.
How did they verify that every single clip in this massive data set was truly on topic?
They brought in the big guns, GPT-4, They essentially asked GPT-4 to analyze each clip and determine if it actually contained content related to the assigned topic. This level of rigor ensures that the dataset is incredibly reliable, which is obviously crucial for research.
Okay, this is starting to sound like the Fort Knox of text-to-video datasets. Meticulously curated, multimodal, verified for accuracy. They really went above and beyond here. But how does VideoUFO stack up against other video datasets out there? What are the key differences?
That's a great question, and it gets to the heart of why VideoUFO is such a game changer. Most existing datasets are built from open domain sources, meaning they just grab videos from all over the web without that specific focus on user prompts. Many of them even reprocess data from the same massive dataset called HD Vilo 100M, which means they're not offering a lot of new information for models to learn from.
So it's like everyone's been drawing from the same well, and VideoUFO is tapping into a fresh spring, so to speak.
Precisely, and to really drive home the point, they did an analysis and found that only 0.29% of the content in VideoUFO overlaps with existing datasets. We're talking about a treasure trove of fresh user-focused data.
And to make it even better, it's all released under a Creative Commons license, right? That open accessibility is so crucial for pushing the field forward.
Absolutely. It removes any copyright roadblocks and allows for wider use and adaptation, which is what we want to see. But it's not just about the quantity of data, it's about the quality and the relevance.
Right, and that's where those 2,000 user-focused topics really come into play.
Exactly. When they analyzed the topics covered in VideoUFO, they found that no existing dataset comes close to encompassing this full range of user-focused content. This really highlights the value proposition here.
So it's not just bigger, it's better aligned with what users actually want to create. But how did they actually put VideoUFO to the test? Did they see tangible improvements in text-to-video generation?
That's where things get really exciting. They developed a new benchmark called BenchUFO, specifically designed to evaluate models on these user-focused topics. It uses real user prompts, generates videos, and then uses a video understanding model to compare the output to the original prompt, measuring how well the model captured the intended concept.
So they're basically asking, did the model understand the assignment? That's a clever way to assess performance. And what did they find? Did VideoUFO make a difference?
The results are pretty striking. They found significant performance differences across topics. Existing models excelled in some areas, often those related to animals, but completely failed in others.
It sounds like even the state-of-the-art models have their blind spots.
They do, but here's where VideoUFO shines. Even a simple model trained solely on VideoUFO outperforms competitors on the worst performing topics, like generating a video about an animal cell or that cyberpunk rabbit we talked about, while maintaining comparable performance on the best performing ones.
So training on a more user-focused data set actually led to tangible improvements. That's huge. I'm guessing there's some pretty exciting visual examples in the paper.
Oh, absolutely. The VideoUFO trained model was able to generate content that other models simply couldn't. It really highlights the impact of training data on model capabilities.
This is incredible. It sounds like VideoUFO has the potential to really shake things up in the world of text-to-video generation.
I think we're just scratching the surface of what's possible here. Imagine models that can reliably create content across a much wider range of user requests, pushing the boundaries of both creative expression and practical applications.
It's like we're finally starting to close that gap between user imagination and AI capabilities. This deep dive has been incredibly insightful. So far, we've covered a lot of ground, from the motivation behind VideoUFO to its intricate construction process and its potential impact on the field.
But there's one key aspect we haven't explored yet. That benchmark they developed to evaluate text-to-video models on these user-focused topics. BenchUFO. This benchmark puts the dataset to the test and reveals some fascinating insights into the current state of text-to-video generation.
Okay, that's a great point. Let's shift our focus to BenchUFO and see what we can learn about how these models perform when faced with those more challenging imaginative user requests.
So we've talked about how VideoUFO is built on these real user prompts, and that already makes it pretty unique, but where BenchUFO really comes into play is in how it assesses the model's ability to handle those prompts, those unusual ones.
Right, because you could have like the best data set in the world, but if the models can't actually use that data to create something meaningful, it's kind of pointless, right?
Exactly. You got it. And most existing benchmarks, they tend to focus on like really common objects or actions, like a bicycle or a car or a person walking, very basic stuff.
Yeah, it's like judging a chef based on, can they make scrambled eggs?
Haha, exactly. It doesn't tell you the full picture, like if they can handle a complex 7-course meal.
Yeah, can they handle the cyberpunk rabbit?
Exactly. So Bench UFO takes those 2,000 topics from Video UFO and puts them to the test. They specifically chose 791 concrete nouns, things like glowing firefly or ancient Egyptian statue or, yep, even cyberpunk rabbit.
So they're really pushing the boundaries of what these models are typically expected to handle.
Oh, yeah. And to make it even more challenging, they took 10 real user prompts for each of those 791 topics. So we're talking almost 8,000 prompts. That's a pretty big test.
Okay, so how do they actually evaluate the models using these prompts? Walk me through it.
Sure. So first, they fed those 8,000 prompts to a bunch of different text-to-video models. Some were publicly available. Some they trained themselves just for this research.
So it's like a head-to-head competition.
Exactly. And then once they had all the generated videos from each model, they brought in another AI heavyweight, Wen2VL7B. Remember that multimodal model we talked about?
Yeah, the one that can understand and describe videos?
That's the one. And it's perfect for this because it can really interpret the scene, not just recognize objects.
Okay, so Qwen2 VL7V watches each video, and then it writes a description of what it sees.
Exactly. And then the researchers compared those descriptions to the original user prompts, something called semantic similarity, basically measuring how well the generated video matched what the prompt was asking for.
Makes sense. A higher score means the model did a better job.
Right. And the results, well, they were pretty remarkable. They found that existing models really struggled with certain topics. There was a huge gap between their best and worst performances.
So even the most advanced models have their weaknesses.
They do. But here's where Video UFO really shines. They trained a simple model called MVDIT just on Video UFO, and it consistently outperformed the others on those challenging topics. It could actually generate recognizable videos for things like an animal cell, an ancient Egyptian statue, and yes, that cyberpunk rabbit.
So the user-focused data set made a real difference.
It really did. They also compared MVDIT trained on Video UFO to models trained on other data sets like OpenVid and VidGen, and guess what?
Video UFO won.
Video UFO won every time. It's a pretty big validation of their approach. You know, shows how important it is to have training data that really aligns with what users want.
This is really cool. I mean, we're seeing firsthand how a user-focused data set can lead to real improvements in text-to-video generation. Are there any visual examples in the paper that really highlight the difference?
Oh yeah, definitely. The paper has some striking examples where the Video UFO trained model created things that the other models just couldn't handle. One example is the prompt, a glowing firefly in a jar at night. The other models really struggled with the glowing effect in the jar itself, but the Video UFO model totally nailed it.
That's awesome. It's one thing to hear about it, but seeing it is a whole other level. I bet our listeners will want to check those out.
I think, so this research has the potential to really change things up in text-to-video generation. Imagine anyone being able to bring their ideas to life no matter how complex.
It's a pretty exciting future, and Video UFO is leading the way. This has been such an insightful deep dive. So far, we've covered a lot, from the idea behind Video UFO to how well it performs.
And there's even more. They also analyze the data set itself, like how the topics are distributed and the quality of the videos.
Okay, a deep dive within a deep dive. Let's talk about those analyses and what other insights we can get from this groundbreaking data set. All right, so we've seen how Video UFO compares to other data sets in terms of content and how it performs on benchmarks, but I'm kind of curious to dig a little deeper into the data set itself. What kind of insights could we get just from analyzing the data?
Yeah, that's where things get really interesting, especially if you're into the nitty-gritty of dataset creation. So one thing that really stood out to the researchers was the distribution of topics. Remember those 2,000 unique topics from the user prompts?
Yeah, cyberpunk rabbits and all of that.
Exactly. Well, they found that a big chunk of those topics were actually related to very specific entities like celebrities or landmarks or even fictional characters, which is interesting because it tells us users are really interested in generating videos about things that are personally meaningful to them.
Yeah, that makes sense. It's like people want to bring their own worlds to life, not just generic scenes.
Right, and that's a huge strength of Video UFO. It provides that raw material for models to create more personalized and engaging content.
So it's not just about creating any video, it's about creating the right video for the right person.
Exactly. We're moving away from that one-size-fits-all approach, and that's where the real potential lies. But they didn't stop there. They also looked at the quality of the videos in the data set.
Okay, how do you even measure the quality of a video in this context? Is it like a subjective thing?
It's a good question, and it's not as simple as you might think. They used a benchmark called VBench, which uses a bunch of different metrics to assess things like subject consistency, background consistency, motion smoothness, and even overall aesthetic quality.
So they're looking at both the technical aspects And like how visually appealing the videos are.
Exactly, because the goal isn't just to create videos that are technically perfect, but also videos that are actually nice to look at.
Right. You don't want a video that's all choppy and blurry.
Nope. And when they ran the video UFO videos through VBench, they found that they scored really highly across all those quality metrics. So that means models trained on this data set are going to be learning from really high quality content, which should lead to better looking generated videos.
That's a good point. It's like giving the AI a good eye for aesthetics.
Exactly. And that's why video UFO is so important. It's not just about having a lot of videos, it's about having the right videos, videos that can really push the boundaries of what's possible.
This has been such a fascinating deep dive.
Yeah.
We've gone from the initial motivation behind video UFO all the way to analyzing the data set itself. We've seen how it compares to other data sets, how it performs on benchmarks, and the impact it could have on the future of text-to-video generation.
Yeah, I think the main takeaway here is that we're moving into a new era of AI development, one that's really focused on the user by aligning training data with what users actually want and need. We can build models that are not just impressive, but actually useful and empowering.
Absolutely. It's like we're moving away from those generic AI models and towards something much more personalized and expressive. Video UFO is a perfect example of what can happen when we put users at the center of AI development.
I could agree more. And as data sets like video UFO continue to evolve, who knows what amazing things we'll be able to create in the future.
It's a really exciting time to be following this field.
Yeah.
And thanks for joining us on this deep dive. And to all our listeners, be sure to check out the show notes for links to the paper, the data set, and some of those incredible generated videos. Until next time, keep exploring and keep creating.